Fabian asked me to present a little bit about, what can we do about AI here in Europe? What are some of the pitfalls? What are some of the experiences, perhaps, that we can learn? How can a startup help big corporations, especially in the European sector? And that's what I wanted to present a little bit out of sort of the past experience. I worked before at Airbus, like mentioned, now part of BCG, so I see a lot of different customers and different clients, different situations, but these are kind of real-world examples, not as much on the research side, so it's not going to be hyper-technical on that, but I think it will help to see how we can drive AI really at the business scale and therefore push it and pull it into Europe. So the thought is really what we want to try and do in the business is we want to start with thinking big, not just have a small technical solution for something that seems to be interesting because AI can now unlock that as a chatbot, but more of, well, here is a big vision. We think with AI we can unlock not a couple of thousands, not a couple of 100,000, but perhaps $100 million for a company. And that might be both disruptive, in a disruptive way, and an evolutionary way. That is to be seen, and some of that is very difficult to apply into a company. But the interesting thing is, after we laid out the big stage, we want to identify where do we start, really. We want to find the key lighthouse project, or 2 or 3, and build out of that. And out of this, create really a drive and a pull in the company to pull in this kind of new thinking. And a lot of that is, unfortunately, trying to change the mindset. And some of that I wanted to present today. So, we've seen these kind of slides already quite often, I'm sure. But what is interesting in the mindset of a lot of top executives is to try to say it's the data now that starts to drive the change. We have now more data, not that we did not create that data before, but we have the ability to tap into that data. And rather than having a very standard approach of engineering thinking, we build something, we see what it produces, we now start looking at the data and see what it tells us, if it tells us the same story as we thought before. But now we have also technology, and technology is the storage layer, it's the NVIDIA CPU set, which is absolutely amazing, but also some of the new algorithms that can unlock suddenly problems that we couldn't unlock before. And the interesting thing is, and that's the gold standard, of course, where we want to get to, is that once we have generated these insights, we want to have them become actionable. So it's nice to have a dashboard culture, not that it gives us that much, but we want to have kind of actionable insights where the system can do something like a prediction and say, I think that and that is going to happen. What are you going to do about that? And see what the result is. Ideally, that will generate even more data, and it will help the system learn. And that's what we're all after, having a system not that just does historical backtesting, but actually can work in the real time and adjust. So in the AI part, a lot of AI talk, and I'm not going to change once more the definition, but a lot of the work that we have been doing is around machine learning, advanced statistics, advanced analytics, but it's been working mainly on the structured set of data that we have available. So this is traditionally in applications, in databases, locked into different silos into the enterprise. And there's huge value that we can drive out of that. Now, interesting enough, though, in most enterprises, if not all of them, 80% of the data that is available is unstructured. So this might be sensor data that is, we don't know what it actually means till we actually look at it from a different perspective, or a lot of documents. And this part is untapped. Well, most of it at least. And that's where the knowledge lies in. And for me, the interesting part of our AI is not looking at just the data and seeing patterns out of the data, but actually compressing the data and turning it into information and now learning about that. So I'm going to show 2 little use cases that I think are a good illustrative. But one of the things that I often show to executives is this kind of slide, which I think really nicely explains where the difference lies between traditional software and rule-based or engineering-based systems and machine learning. So you have on the left side, you have sort of the kind of expert-built system, somebody who has really a lot of knowledge, and we thought about how we're going to do something. So you have the data that comes in, you have the rule sets, and you have then an output. Out of that, we'll see how it reacts in real world, often different than we expected. There's a lot of chaos going on, and then we need to adjust it. So the difference to machine learning, the thinking of it is different in that we think about the input data in the same way, but we now take the output data from the past, and out of that we derive the rules. Seems very, very smart, has of course a couple of problems. But in essence, we learn first from the past, like we all think the way we learn. And out of that, we want to sort of create, this is kind of the adjustment of the rule. And the interesting thing is that as it goes along, the circle can continue, and we can just adjust the model. So new data, we get new rules or refined rules. Now, how does it look in reality? So, if we look at some of the applied AI, a lot of the business in Europe, in Germany especially, is around manufacturing. That's where we're king at. A lot of the manufacturing is also a high level of outputs. But one thing is, how can we attack this? How can we change some of those aspects? And of course, quality, made in Germany, is a big thing. And that's why it's some of the core use cases that we see in a lot of the industries here. Now, here's a use case that we did in the past. We have a customer who has a new product, wants to ramp up that product at the beginning before you go really into mass production. You have a lot of quality issues. Now, this is a new product, so you can't really learn from the past, can you? Well, depends. You might have had past products that somehow resemble. And this is something where we can use machine learning for, right? Machine learning is good to compare apples and oranges. Like I usually give my example on that, where can you compare apple and oranges? Well, the saying says no, but machine learning says yes, if you're looking for a fruit with high level of vitamin C. Both work. If you want to have something that's kind of round, yeah, both work. If you want to have something that you can throw on the head of somebody, both work. But if you look at a color coding, they're not. So given the context, we can see supposedly different situations suddenly being the same. So in this case, what we did is we looked at hundreds of thousands of past issues, and we tried to extract using natural language processing, so handwritten, sometimes machine-written notes to sort of discern what is the same, what is not, and present that to the human operator as a point of decision, saying, the issue that you're facing right now, we think we saw something similar in a different station, different product 2 years ago. Do you think it's the same? So, we thought we're doing good. We're putting the actual decision back to the humans. Now, the humans are actually really smart about that. They are experts. And they can say, yes, that's the same issue I'm facing right now. So the system, great, learns and says, well, if that's the same issue, can we use the same kind of solution that we used to apply last time that worked good versus the bad one? Why don't we do the same solution path? And with that, we can actually show a tremendous amount of effect. So you can speed up production time, you can speed up root cause analysis, and you can have a stoppage of the typical hands up. So you have a problem, listen, I can't decide, I don't have all the information, that's somebody else who was in this station who might have that information. Now we're unlocking that and bringing that to the shop floor. Sounds all good. Now there was just one little problem, is that we knew that the prediction rate is 87%, meaning that in 87%, we knew that the algorithm would probably spit out the correct answer, the correct hypotheses. After a couple of months, the prediction rate went up. And we thought, yeah, it's great, the system learns. But it went up to 100%. And so that's where we thought, that there might be something wrong. So contrary to what we were thinking, that the humans actually train the machine actually trained the humans. It was so good that the human said, this is right, yeah. Next time, this is right, yeah, this looks good. Next time, it's like, yeah, I know this is good. So yes, yes, yes. So they answered more often yes to the system than the system actually thought of himself. So the trust issue sort of reverted to what we didn't think, and which is a problem, because all of you know about biased data. Now, even worse does it get when we create biased data. We know that it's wrong in 13% of the cases, but these are being ignored, and the system just feeds on its own bad behavior. So we actually had to put in guardrails to say the system said, yeah, I think that's right, but I think you should say no, which seems a little bit counterintuitive. But I think it highlights one of the problems that we have where we want to create a self-learning system that wants to learn out of the human output, but we're actually controlling that output. So I think that's something to be taken into account when we look about the data in real life. I brought in another example, which I really liked, because I thought when I started this project, there's really cool AI in there. Turns out I was wrong. So this was a problem where you have a lot of general ledger spend, so it's the ins and outs, of a company that buys goods or buys elements or, travel, all kinds of expenses. And they want to map it. Usually you have it mapped fairly well. Most of the time in reality, there's a lot of uncertainty and a lot of wrong bookings in there. So we have, on the one side, a general ledger. On the other side, we have around 300 cost categories to which we want to map these kind of expenses. So I said, hey, good, let's do some NLP, NLU, to try to find out that. So you have sometimes invoices. Fortunately, it turns out that those invoices of multinationals are actually multi-language. So first thing is try to translate that, which comes out to be a little bit challenging in certain cases because it's specialized language and doesn't translate all that well. Could we work with this? And then you have this big blob on the right side, even though we already extracted what we think is the most relevant aspect of the invoice to categorize it. Now, out of that, these are the things that you need to extract. In this case, it was actually quite simplistic, that it was like keywords. How do you find these? And how you do that with over 100 million or 1 million cases of these invoices? And, of course, being BCG, in 6 weeks, right? So there are other companies that use thousands and tens of thousands of people, actually, in certain countries to go through these very quickly and try to classify them. And we said, can we do that better? Can we do that like with a couple of orders of magnitude better, with 8 people? Interesting enough, we could. And this is the approach. Remember the invoice I showed you? So if we have that big blob of text, how do we condense it? Remember that AI, in my opinion, is about trying to extract the information out of data. This is very loose data, so meaning that there's a lot of words, but what's the information in there? So we go successively through it, and what we try to find, let's see if this comes over, we look at different elements of the text and we see, oh, wait, this is a whole phrase. Phrases typically, because it's a sentence, it's explanational information, does not relate necessarily to the information I want. Get out. We have superficial information such as names, locations, and that's not important. One could think, but if I have something like, I have a flight from London to Munich, it doesn't really matter that I have London, Munich, if I can replace them by city, so that I have multiple flights suddenly fall into the same category. So we're condensing further the information, or we're throwing it out. Then we get superficial information, fill words, etc., and successively reduce the amount of data in there till we extract the number of keywords that are relevant to it. So what we wanted to do is really to combine a little bit the this kind of methodology with a very high-speed working of that. And what we're able to do is this kind of method. So first, we have the 800,000 invoice data. That is kind of like messy, and we cannot go through all of that. Our goal is to reduce this to something that's more reasonable. With a structured approach that I just showed you, we condense this data, we look at the similarities of that, and we try to find, what can we group together that we think belongs together. And suddenly we're down to 40,000 things, 40,000 groups that we can now treat as. Now what we do is we see which ones of them have the highest spend. And usually in a Pareto analysis, you can see that in this case, 5,000 of those groups actually map to almost 90% of all the remaining spend. So I actually only have to concentrate on those. Now 5,000, what's interesting is, became such a manageable number that we said, oh, that's like kind of 2 weeks for 4 people to go through. So we could actually just do manual stuff. But let's do some machine learning. So let's have some smart AI try to figure this out. Actually, it was harder than we thought, because in the first instant, those kind of invoices are quite esoteric. Let's say you're a coffee brand company, you buy a lot of milk. Well, is that, for another company, this might be something for the cafeteria, just in a different spend. For that coffee company, that's actually part of the resources and is capital spend. So we cannot treat it the same way. We have to generate a context that is common between those. And what we think is, after having done 20, 30, we can build up a kind of context-sensitive interaction. So we want to start quick, but build up this database of context-aware knowledge that can use that. So with just a simple set of rules, we can actually spend most of that. Now, and this we validate with humans, and then we train our machine learning algorithms. As of now, in the first case, machine learning actually just accounted for additional 15%, but that can grow significantly. The interesting thing is this we can now do just without super duper AI, but just a very data-driven approach. We can have very quick results in very short amount of time, and therefore collect in the time that it takes others to go through 4 or 5 customers. We can do 100 of these and create at the same time this machine learning database in the back end. So I wanted to stop the talk on just a little bit of the kind of approaches that I think work really well if you're a startup or if you're a tech company, to go and gain traction in some of the businesses, especially in Europe, where we have a lot of engineering focus. What is important are 2 aspects. One, they are not data-driven thinking. I mean, we heard that a lot of times, but the whole organization is not necessarily set up like that. If you are in a small function and you succeed in helping that small function, the question is, how does that get reused later on? So what we need to build as well is this thing is big. And I think what I try to tell always to executives is, Fabian tells the same thing, AI is a disruptive technology. Now, what does that mean? Then can we do things better? Yeah. But the interesting thing is most of the AI disruption means destruction for the incumbent. And dear customer, you are the incumbent. So they need to move. They need to move very, very quickly and not just do things better that they used to do. We need to actually try to map the entire process chain, the value chain, see if we can redo it in a completely different way or extend that value chain, right? Is it enough to just sell a product? Or do we need to think about selling the service around that product? If I'm a car producer, of course, standard example, but what is the service that I'm providing? It's transportation, right, from A to B. Well, I never went from A to B. I don't know about you, but I went from a specific origin to a specific destination. Now, my car doesn't know that. My Tesla perhaps does. It asks me, it looks in the calendar and sees the kind of location and knows where I want to go. And perhaps if I want to go to my mother-in-law, perhaps I don't want to go the fastest way, but perhaps the most scenic way that's relaxing. Whereas when I want to go to work, what's interesting, and after 10 years I have the same car and I go at 8:30 into my car, it still doesn't know that I want to go to work. Yet I have a smartphone that costs a fraction that does learn about that. So there's a disconnect, I think. It's not the technology that is not there, it's the thinking that's not there. So we need to attack at the value chain and say, what does autonomy, for example, mean for a car? Does it just mean that you have a cool car running on a battery? Or does it mean that you're not going to produce that many cars, and that suddenly your business model is going to change? And I think that's the important part, that we need to go into the vision on the top level. And then attack with a use case that they can actually see, okay, I get it now. And now you need to find the balance. Do you attack on the core business and see how they can revolutionize it? Or do we do a separate part where they just say, we built up a new company that's going to eat our own dog food, or that's going to eat our own cash cow? And I think this is where we need to find the balance, right? A lot of the startups in AI that are successful disrupted the market. And a lot of the successful players like Amazon that have stepwise evolutionized throughout this journey are now eating one business after the other, because they have this massive advantage of a platform strategy or an AI strategy that completely revolutionizes the way that we do business. So here is a great opportunity, I think, for us, because what we have in comparison to the US, we have a lot of industry here with us. The US has outsourced a lot of that, and they're trying now to bring it back. I mean, think about it, that Tesla has its main production company in California, in the Silicon Valley, the most expensive workforce there is. But it is crucial for the way that they want to produce their cars. So they're trying to bring manufacturing back. We have manufacturing, we have data. Let's use it. Thank you.